This video is going to be about using the method to complete the square, right? Solving a quadratic. We've solved quadratics by completing the square, but now we're going to use the same strategies or the same steps, not to solve, not to find out what happens when f of x is equal to 0, but to translate our forms from this standard form, in which f of x is equal to ax squared plus bx plus c, into the vertex form, in which f of x is equal to a times x minus h squared. Notice there's a perfect square here, plus k. And the reason we want to do that is, of course, in vertex form, the vertex is relatively easy to see because it is the point h comma k. So this gives us a nice way to go ahead and graph a parabola. So there's a few things that I'm going to want to do. The first thing that I want to do is I'm going to replace f of x with y. And the reason that I'm going to do this is because unlike in the other systems where I'm solving, this y is going to sort of stay with us in our equation throughout all of the steps. And so having it written as y just keeps it a little bit more compact, keeps us a little bit more clear about what we're doing. The second thing that I'm going to do is I'm going to check that my a value is equal to 1. If a is not equal to 1, I'm going to have to divide everything by that a value in order to ensure that the a value is 1, okay? So here it is 1, so then I'm going to go on to step 3, which is that I'm going to move the current c value, right, the not so compatible c, over to the left-hand side. And when I do that, it's going to sort of live here together with this y. So now I have y minus 5 is equal to x squared minus 2x. And now I'm going to complete the square of the trinomial that I'm building on the right-hand side by taking half of that b value, squaring it, and writing that as the new c. And then I'm going to add that c to both sides. So in this case, I've got -2. Half of -2 is -1. -1 squared is +1. So I'm going to add 1 to both sides. So now I've got y minus 4 on this left-hand side is equal to, and now because this is now my perfect square, trinomial, I can complete the square. I can write it as a square. So this is x minus half of b, and it's a minus sign because of the negative in the middle. And so now here's my square, and then I can just go ahead and move what is now my k value, right, back onto the right-hand side. So I'm going to add 4 and add 4. So y is equal to the quantity x minus 1 squared plus 4. And so now the advantage of that is I can go ahead and I can make my table of values and graph it because I know that the vertex is 1, 4. So I can go ahead and just sort of find some values around that. And I can also remember that the axis of symmetry here is x is equal to h. So I can use that, whatever these values are going to be mirrored on the other side. So let's go ahead and plug in some of this information to graph it. So my axis of symmetry is going to be here at x is equal to 1, right? Is my axis of symmetry, looking here. And my vertex is going to be 4 up along that line, 4 up along that axis at 0.14. So now let's figure out what value we'll get when we get 2, and that will be the same value that we would get at 0. So I'm just going to plug in 2. 2 minus 1 is 1. 1 squared is 1. Plus 4 would be 5. So it's 0.25. And so this must be mirrored on the other side. So 2, 5, and 0, 5. Now maybe I'll plug in 3. So 3 minus 1 is 2. 2 squared is 4. 4 plus 4 is 8. And so negative 1 would also be 8. So at negative 1, 1, 2, 3, 4, 5, 6, 7, 8. And at 3, 8. And again, I'm using this sort of idea of mirroring to help me envision my shape of my parabola. And I'm going to sketch it in there. All right. So now let's take a look at an example that what will happen when we have a leading coefficient that is negative. So I'm going to sort of follow the same general steps from this other side. In fact, let me, just to save a little bit of time. Bring these over. So I'm going to, oops, there the equations go. Okay, I'm going to replace this f of x with y. So I'm going to rewrite it as y is equal to negative 2x squared plus 8x minus 9. And now I'm going to double check that a is equal to 1, and it is not. So I'm going to need to divide everything on this side by negative 2, okay, because that a value is right now negative 2. So now I've got y divided by negative 2 is equal to x squared minus 4x plus, I could write it as 4.5 or 4.5. I'm going to write it as 4.5 just for difference sake. And then I'm going to move this c value that I have over to the left. So notice my sort of left-hand side is starting to get a little jumbled. So I have to be very careful to keep everything written sort of in order. So I've got y divided by 2 minus 4.5. And it, again, I have to be careful that I don't mess up my order of operations, right? So this would be done first, and then this is being sort of brought to it later. So now that's x squared minus 4x. And then I'm going to go ahead and find my dream c value here, and I'm going to add that to both sides. So I'm going to take half of b, which is negative 2. I'm going to square it. So I'm going to add 4 to this side, and I'm going to add 4 to this side. So now I have y over negative 2 minus minus 0.5, 0.5, or a half. And that is equal to, and now I can write this in factored form, so x minus 2, take half of that b, squared. So now I can go ahead and add I'm going to add it as a half back onto this side. And so now I've got y divided by negative 2 is equal to x minus 2 squared plus a half. But I'm not done because y is not by itself. So I have to, on this side, I have to multiply everything by negative 2, which means on this side, I have to multiply everything by negative 2. And I have to distribute that in to both of the terms. But I got to be a little sneaky or careful because my first term is this square. So I'm actually just going to rewrite that as negative 2 times this squared term. I'm going to leave that squared term intact because that was the goal, being able to do it. So negative 2 times that squared term, and then I'm going to distribute this negative 2 to this value here. So negative 2 times positive 1/2 is negative 1. So y is now equal to negative 2 times the quantity x minus 2 squared minus 1/2. So again, the thing that I just want you to pay careful attention to is that when you're distributing this negative 2 back in, 1 will end up as our a value, sort of right in front of that squared term, and the other factor, and then it also needs to be distributed into whatever that addition or subtraction part was in the second one. So it's going to actually be distributed back in. Okay, so then I can take this equation here that I've got, and now I can come up and I can graph it. Because I'm in vertex form, so I can find the vertex here would be 2, -1. So x and y. So my vertex is 2, -1. So at 2, -1 is my vertex. My axis of symmetry would be x is equal to -2. I'm sorry, +2. Don't forget that that's a minus in the rule, so you got to switch the sign. So x is equal to 2. So there's my axis of symmetry. And then 2, -1. So then let's just check some other values. So I'll check sort of 3 and 4. So I'll plug in 3. So 3 minus 2 is 1. 1 squared is 1. 1 squared times -2 is -2. -2 minus 1 is -3. So now I'm at 3, -3. And on the other side of that, I would be at 1, -3. And then maybe I'll do 0. So 0 minus 2 is -2. -2 squared is 4. 4 times -2 is -8. Minus 1 is -9. And so my y-intercept is 1, 2, 3, 4, 6, 7, 8, 9. 0, -9. And then on the other side, reflecting over, it would be 4, -9. Okay. And so I can now use that information, to graph we said that was -9. So I can use that information now to hopefully graph my parabola. Missed a little bit on that side. Okay. And so hopefully that can help you sort of connect the pieces here between completing the square, which we can do to solve by making that f of x or that y value equal to 0, and translating between standard form and vertex form. Thanks.